Hello and welcome back to the lecture series on algorithmic problem solving. This video is about the power of XOR, a powerful bitwise operator that can be useful to solve most of the problem related to bit manipulation, and one can see the power of XOR when examples are being discussed. But before proceeding towards the example, first let us understand the properties of XOR, and these properties should be remembered so that it becomes useful while solving problem. First property is that X XOR with 0 results in same number X. Second property is X XOR with itself results in answer of 0. This can be verified by the table that was shown in the bit manipulation video, where the two numbers are like A and B, and these two can take only binary values like 0 or 1. So there will be 4 possible combinations: 0, 0, 0, 1, and 0, 1, 1. And based on this, XOR has to be calculated, and as it was discussed that the same values results in answer of 0, while different values results in answer of 1. So same thing can be applied to any number, irrespective of whether it is in the binary form or decimal form. This will result in X and this will result in 0. Third property is that XOR is associative. Means, so let us consider 3 numbers where XOR takes place: XOR of X with Y followed by XOR of Z. So this means that XOR of X XOR with Y Z first are equivalent, followed by X XOR with Z followed by Y. These are the 3 properties or 3 values for which XOR values will be same, and this is also a critical property and it should be remembered. Another property that is XOR is commutative, and looking at this, one can say that given a 2 number X and Y, one needs to figure out X XOR Y. This is equivalent to Y XOR X. So both answer will be same. What if the numbers are 3 like X, Y, Z? How will the commutative property hold in that case? X XOR Y XOR with Z, following the same convention as followed in the associative. So X XOR with Z XOR with Y, and this can be equivalent to X XOR with Z XOR with Y, and this can also be equivalent to saying that X is Z XOR with X XOR with Y, and here the order doesn't matter. We can say that Y XOR with X XOR with Z is also possible. So there can be many possibilities, and using these properties one would be able to solve problems related to XOR. Properties of XOR, where how one can toggle a bit, was discussed, considering X as a number, and by left shifting by J unit, where J is the bit which is to be toggled, and taking XOR will toggle that bit. This was the example that has been discussed. Now moving on towards another example where XOR finds its application is in-place swapping. There are two concepts here, or two things that has to be discussed. First is in place and second is swapping. In place means without using any additional space. That is the idea of in place. Or to simplify this, one can say within same memory space. Not memory location but memory space. That means consider a number A or some number. So swapping should take place within this memory. And we don't have to take another additional memory. That is the meaning of in place. Second thing, that is to swap means change the, suppose this is the value stored in memory location of A, which is some value, let's say 5. Then in B some other memory values will be stored, which will be 6. So swapping means using the same location of A and B, just get the value swapped. So this should have the value of 6 and this should have the value of 5. This is the meaning of swapping. Now how to, first let us try to solve it by using addition and subtraction. How swapping will take place by using addition and subtraction. So consider these two values, like A will be 6 and B will be 5. Now one needs to swap this by using addition and subtraction. So first, so in turn A will now have the value of 11. B will then take A minus of B, which is 11 minus of 5, which is 6. Now B will have the value of 6. Again consider A of A minus B, where A is still 11 and B is 6 now, because this value will be used here, because initially it was 5. Now after this operation, this is replaced with 6. So this value will be used, hence resulting in answer of A getting the value 5 and B getting the value of 6. Similar idea can be exploited while using XOR property. How will that be? This is in place. This is in place swapping, but without using XOR operator. How swapping will take place using additional memory, and let us understand it visually. Let us say this is the address location of A and the value stored here is 5, 6 and B is 5. Then consider another memory location which will have some value initialized to this. And now first step is move this value to the empty space. This would be the first step. Now C will have the value of 5. And second step is to move A towards the empty space, which will be B. So now B will have the value of C, 6. And third step and the final step is to move A, C value to A. This would be third step, resulting in answer of A equal to 5, B equal to 6 by using additional memory. So this is not in-place swapping. Also considered, now we have looked at what is in-place swapping. Now using how addition and subtraction has taken place for swapping, similar idea can be applied for XOR, where consider A, which will be A XOR B, then B will be B XOR of A, and finally A will be A XOR of B. You can compare this with these steps of A minus B and A plus B. So this is equivalent to saying like this step is A plus B analogous. This step is analogous to A minus of B, and this step is analogous to A minus B. Thank you.